Hey, what's up guys? So a lot has changed since the end of last video, and unfortunately I did film it all, but the GoPro with its memory card went missing. So try and catch up to speed. Basically, we are just about ready to get going on fabbing and welding our whole frame, and we've got this really cool jig system set up. So basically all of these brackets were modeled, and we've got CAD of the whole thing, and basically the tubes just slot into here. We've got a split clamp, we'll show you more later, but basically it presses down and holds the tubes in perfectly. And all of these will hold the tubes perfectly in line and hopefully give us a very accurate frame to build off of. So this was the, this is our new mascot. This guy just appeared one night, but this is our roll hoop. We did that in a separate jigging setup, and it worked awesome. So we've just got a few more pieces of the jigging to water jet out. So we're gonna head over to the machine shop right away and cut these out, show you how they're made, and then we'll weld them up and get to assembling the frame. So what are you doing here now, Damien?
So we're just setting the thickness here. So this is adjusting the stop that controls, how far down the jaws will go. So we want to make sure that we're only pushing it as it bends, and we're not then trying to squish our material. So yeah, we're just getting that thickness set so it goes all the way down. We're checking to see that it just slides in but still tight, and then that's right about it. Come on.
They've got a really nice welder in here, Dynasty 350 with a water-cooled torch and everything. So I'll come in here anytime we need to weld aluminum, and it's a nice welder. Perfect. So the whole reason why we wanted to put a little bit of a bend in this was to give it some stiffness, because well, these slots here have tabs that will be coming out and supporting the roll hoop. So this just gives it a little bit more bending rigidity. But now we'll move on to cutting out the rest of the jigs on the water jet. So this is Omax Maxim water jet, and this is it's a little bit of an older model, but it's got a very big bed size, which means we can do some pretty big cuts in one go, which is always stressful, but it helps increase your productivity. And Damien's the water jet whiz kid, so you gotta trust his programming. And so for anyone who doesn't know how a water jet works, is it cuts out metal. You can go up to really thick pieces, all sorts, aluminum, steel, even wood and carbon fiber, and it does it by shooting a pressurized jet of water out the nozzle, mixed with an abrasive sand. And so this sand is what tears away at the metal and cuts through. So I'm going to start by zeroing in the machine and getting the piece set in there.
myself, but it's like I was too weak to be someone else. Good thing that I'm a creep when I...
Well, here's the pieces, and we ran out of sand with 39 seconds left. We just weren't paying attention, but we got little tabs on them, so we just bend them out, and that's it. So, ghetto testing and data acquisition and validation is better than none. So this is how we're calculating our brake pedal force.
Oh, we got to 100.
Ooh, right on. So this is Jenny, and she is pressing on just a regular old bathroom weigh scale in a position to try and replicate the seating position in the car, and by seeing how much she can push on the pedal, we'll know how much force we can input into our braking system. Then we'll throw it into our MATLAB and calculate the rest of the parameters like leverage ratio and the ratio of the piston diameter, so we can actually stop the car. Oh, look at that! Maxed it out!
What?
What? No. Wait, let's see. Go again.
So we've got a variety of drivers with different strengths in their legs, obviously, and so we want to try and make the vehicle accessible for a wider variety of drivers. So we want to take probably one of the lighter braking forces so that the weakest driver could lock it up, but then in the rest of our calculations we'll use the heavier mass, or mass of a heavier driver, to try and give us that worst case scenario loading and make sure we can lock up the brakes under any circumstances. So this is part of our MATLAB code for calculating the required brake parameters. So basically in your brake system there's a few things that you can select to optimize and just find out the size. You have to account for the mass of the vehicle, there's weight transferring forwards, radius of the tires, radius of the brake rotors, number of pistons on the calipers, number of calipers you have on the car, because we just run a single caliper in the rear, and basically the ratio of the piston areas gives you your force, and the leverage ratio of the pedal it all comes back down to how hard the driver hits the brakes. So that's what that test was for. It was to check the driver brake input, and then we can run through the rest of the parameters here to optimize, and then head over to our manufacturers and see what they have in our size range, try out a few different combinations, and then order some parts. Well, you got another busy work day today. Lots of people in here doing lots of good work. Got some modeling going on, and then the frame is coming together. So we finished building all the jigs last night, and now we're just doing the final prep on the tubes, clean them down with some acetone, and we're gonna throw them all into the frame here, or into the jig, and got everything assembled, check all the dimensions and angles, and then tack it up. Okay, so we've got all our tubes prepped, and now we're ready to throw them into the frame jig. So we've got them prepped all the way on the inside and the outside, and then wiped down with acetone. And so with TIG welding, the prep is super critical. So the more effort you put into the prep, the nicer your weld can turn out. So we've got everything prepped to bright shiny metal, and then wiped down with acetone. What was the method? So now we're going to go ahead and start throwing these in and fit it up. frame's coming together. We've got all our jigging holding these floor plane in, and we're working on getting the front end and the upper ones. Damon's gonna throw in the roll hoop. We're a little short on our big M16 fasteners though, so we've got a bunch more braces that are supposed to go in here, but fortunately those fasteners don't come in until Monday, so we're just going to do what we can for now, and then when Monday comes around we'll throw the rest in, and hopefully it'll be quick.
There's no one coming here to save you. You've got to save yourself. We're walking back to destruction. How can you live when you're part of the problem? They will find you and take everything away from you. I'm so sick and tired of the waiting. I don't have the time or the patience. Who do we think we are?
So everything's coming together super well. We're just getting the last of the front tubes in here with their cross members, and then we'll start tightening it up and aligning things. So you see there still are some tiny gaps in some spots where things haven't been fit up yet, but then down like back here that fitment is pretty close to perfect. So this whole jigging method is by far and away better than anything we've ever done before, and it's hugely thanks to these two right here. David and Jenny killed it on all the frame design, and designing the jigging is a huge undertaking as well. But it's just making assembling it so much easier, because we're just pop everything into place, and then we're still gonna be checking critical measurements. Okay, so we've got the frame fully jigged in, and everything is as close to perfect as we can get it, I would say. So it's finally time to start welding the frame. We've got all the floor and firewall is in there pretty perfectly, I think, and so we'll get started. We also just got this packaging from Fabricating cups. It's the FUPA 12 in ceramic. It's basically the same deal as the glass cup, but a little bit less fragile. We just broke the other one of these, so we figured we'd pick some of these up and see how the ceramic ones do. So I'll throw one of those on and get to tacking. Nice. So the other nice thing about these cups is they're actually threaded for that number 17 torch kit, as opposed to relying on an O-ring and just kind of a press fit. The clear ones do look super cool, especially with the little titanium protective ring around there. But we'll save that one for special occasions maybe, and give this one a shot. Okay, so we got the floor plane and most of the upper roll hoop tacked in there. It's looking pretty good. There's a few spots where it got a little hot, but so far it's coming good. It's a little tight getting into these back spots here, but overall this jigging is making things super helpful, or super useful. And there's some tight spots up in here too, but I'm really excited how this is going. Team's gonna have a sweet car. The frame is pretty much fully tacked now. Tried to get 4 points on every tube where I could, and then started fully welding in a couple sections here, and that's just so that we can make sure those tubes are fully welded all the way around before these extra tubes go in there. We've got a couple more diagonal braces that are going in there, but overall it's coming together very well, and this jigging helped immensely. And so we've got most of those plates out of here now because well, the frame's holding itself up. So now we've just got to go ahead and keep welding these up. The welding's been going pretty well. In order to try and minimize distortion and balance the heat, what I've been doing is kind of split all the tubes into 4 quadrants with tacks, and then so I'll weld one side of the tack, a quarter of it, and then the opposite side, then move on to another tube, do the same on the opposite side of the frame, and come back and then do those final 2 quadrants. And it seems to be doing quite well, and we're getting some nice colors out of everything, and it's just showing kind of our heat settings are dialed in, not bad. And this FUPA 12 cup or gas lens with the diffuser is being really helpful, especially for, you know, getting into tight areas like that where there's not a chance you would have fit that in there with like a number number 8 or number 9 cup or whatever. This thing's been really nice, and it just gives us that maximum gas coverage, so that we do get those nice kind of colors trailing out, and the prep is a big indication of that as well. So, you know, wipe down bright shiny metal down to acetone, and then hopefully it makes for a nice high quality weld.
If I bleed tonight, if I am sad tonight, I don't have a job to find. And if I work tonight, if I'm so tired tonight, I'll fall asleep when I'm home, when I'm
So last night Damien got the whole back half of the frame jigged up, and so we'll go ahead and start tacking this in. Our back end got pretty tight, and it's looking nice, and so we'll go ahead, get that tacked in, and he also got our diagonal members here. Let's just add some awesome triangulation and strength to our cockpit.
I was just so far from here, focused on my own way, with never looking back to those who lived in fear. There was nothing I could do, there was nothing you said that could make me realize how much lucky I was. Just out of reach.
So that's pretty much everything. These sidebars are tacked in there, and you know, you're gonna get sick of me saying it, but this cup is amazing because it'll let you get into those tight spots, all these tight spots, everywhere up here where it's just way too difficult to get a normal cup into, you know, because you can have that tungsten stick out and still maintain your gas coverage. Back end is looking really nice. I really like our design here where basically the front half of the frame is kind of separate, and then we've got this one piece that just kind of loops in there, ties it all together really nicely. And then both of these up bars here are one piece continuous with a couple of compound bends in there. And it's a really nice tight packaging. This is where our fuel tank's gonna mount. And we've got a lot of open room in here for accessing our CVT, our drivetrain, our gearbox and all that. Team's done a phenomenal job so far this year, and you know, we keep looking on the up and up, and I think we're gonna have a very competitive car. So Damien got pretty much the rest of the tubes fit up here. We've got a couple extra gussets and braces, and the tow bar. This is really, I like our sleek, clean tow bar. These little bends that just go smoothly into the rest of it, and works good for bashing slower cars. And then a couple pieces in the back here jigged up. So quickly tack those in, and then there's these sidebars here, and then we'll get to welding the rest of the chassis. So the welds are coming pretty good. It's funny, some of the ones in the tougher positions turn out nicer. So these ones I did in position overhead with my right and left hand, and not too bad. So we realized right after I started tacking this one on that I hadn't actually finished welding this tube yet. So we broke those tacks off, and then I came back in and welded the inside of this tube first. So that's just important, especially on critical ones, but you should do it everywhere. To fully weld 360 around each tube before the next new tube comes on, especially with this being a primary member. So we got that sorted out, and now I'll go back and tack this on and then weld it up. We got our first shipment of bearings in from SKF today. Got some big ones, some little ones, and these are all going in our gearbox. And we're also getting some rod ends from SKF. SKF's a huge supporter of Baja SAE and Formula SAE, and well, they're one of the leading, world's leading bearing manufacturers. And you know, they really treat our student teams right. We've got extremely fast shipping on all their stuff. As soon as it's available, it's out your way, and great quality products as well. You know, we haven't had any issues with them at all. They're awesome bearings. So glad to see some parts rolling in, and let's keep building. So just working on taking off one of the last main jig pieces here, so that I can get down and access these bottom joints, because they're pretty tight. But you can see these brackets here, they held our two main vertical tubes, and they clamped in and just held everything nice and square and straight up and down. And so now that basically everything around here is all you know, tacked in and then also welded at least halfway around the tube. I'm gonna pull this off so I can get down these guys, and hopefully they haven't moved, because those are some pretty critical locating members for our suspension, and gearbox mounting gets pretty tight in there too.
I can see my life is crap. I have to see them too. I just live into my world, far from the pain, the fear. Just out of reach of desire. Was not aware of starting out. But when I stop to see you, I'm thinking for you.
here she is. It's Sarah, fully tacked together. It's gonna be a good looking frame. So that'll be it for this episode. There's still a little bit more welding to do on the frame, but I'm sure you've seen enough welding time lapses by now. Catch you in the next one.